Hey Panthers, it's Mrs. Sherburne and I'm back with video 4. If you haven't checked out the first 3 videos, you're going to want to do that. This is part 4 of a 5-part series. In the first 3 parts, we talked about a single replacement reaction, combination, and decomposition. Today we're going to focus on either double replacement or combustion. You'll find out in a minute which one. All the while that we're doing these different demonstrations and 5 videos, I want you to focus on these 3 things. Being able to balance the chemical equation, identifying which reaction type it is, and drawing a particle model of the reaction. All right, let's take a look at what I've got set up over here. So in these 2 jars, I have 2 clear, colorless liquids. If I didn't have labels on them, you'd probably think they could be water. So this one is sodium hydroxide. It's more commonly known as soda ash. Or lye, L-Y-E. This one is magnesium sulfate, more commonly known as Epsom salt. And I really did just make this compound here at home using magnesium sulfate, Epsom salt, right from the grocery store. So what we're going to do is take a look at mixing these 2 clear, colorless liquids. I'm going to turn them around so that you can see them a little bit better and the labels aren't in the way. Really zoom in close because here we go. And I don't really need to add it all, but I hope that you can tell that there's some solid that's developed in here. It almost looks to me like toilet paper that's been left in the toilet too long, maybe. So let's talk about this chemical reaction. All right, follow me over here. Okay, so we have the reaction between magnesium sulfate, that's the Epsom salt, and the soda ash, or sodium hydroxide. And we're making magnesium hydroxide and sodium sulfate. If you look at the names, you can probably see kind of a switcheroo happening. So it's almost like magnesium combines with the hydroxide, and that's written over here, this one. And then the sodium combines with the sulfate, and that's written over here. Both of these solutions are aqueous, or mixed with water. And I know some of you are wondering, well, how did you know what the formulas were? And that goes back to our gold sheet and what the charge of the ions are. So I left a little bit of space up top here. And if you look at your gold sheet or your chem info sheet enough, you'll have the charges of the ions just memorized. So magnesium is 2+. Sulfate is a polyatomic ion. This cluster, the whole thing, has a charge of 2 negative. So if this is 2 positive and this is 2 negative, I needed 1 of each to make the formula. Sodium hydroxide is Na+. OH is the hydroxide ion, and this whole thing is also -1. Well, if this is +1 and this is -1, I only need 1 of each. So that's how I came up with those formulas. But now essentially what I'm going to do is I'm going to do a switcheroo up here. So Mg2+, if Mg breaks up with SO4 and is not interested in SO4 anymore, between these 2, which one do you think it's going to be interested in? And if you said the positive is attracted to the negative, you are right. So I'm going to combine this one and this one, positive with negative. But if this is 2+ and this is -1, I'm going to need 2 OHs in order to balance that formula, which is where that 2 came from right there. Okay? All right, so now this leaves SO4 to combine with the Na+. We always write the positive ions first, which is why Na is positive over here. But notice the 2 right here. That's because Na is just +1, SO4 is 2-. I'm going to need 2 of these to balance the SO4. That's where that 2 came from. Okay? So if we're good with that, then let's take a look at kind of our picture here. And remember, we're trying to have the same number of each atom before the reaction and on the product side after the reaction. So color coding it makes it really nice. I've got 1 Mg on both sides. I've got 1 S on both sides. But I've got 1 Na here and 2 NAs over here. So I already know I'm going to need to draw that one again. You can pause it. All right, so let's add 1 more sodium hydroxide. Is that green? Yeah, that's green. O and H. Okay, my NAs are good. Now I guess the last thing we've got to count up are our hydrogens and our oxygens. So on this side, I have 1, 2, 3, 4, 5, 6 oxygens, and on this side I have 1, 2, 3, 4, 5, 6. Perfect. And I've got 1, 2 H's, and I've got 2 H's on that side, which that will let me pretty easily write my coefficients in front. If I only have 1 molecule or formula unit here, you can write a 1, but you don't have to. Here I have 2 formula units of sodium hydroxide, so I'm going to put a 2 there. There's 1 of those, you don't have to write a 1, and there's 1 of these. You know, speaking of, if I look over on this side, we talked about the reactants that we started with being aqueous, but we didn't talk about which one, magnesium hydroxide or sodium sulfate, which one of those is the white precipitate, the white solid that we made. So let's take a look at something to figure out which magnesium hydroxide or sodium sulfate is the white solid that's in here. All right, so to determine between magnesium hydroxide and sodium sulfate, which one is the white solid, we're going to use this solubility table. So the first thing I want you to find is Mg along the top, which is right here. Kind of works like a multiplication table. Mg, and over here are all the negative ions, and I'm going to match it up to OH. And it turns out that MgOH2 is insoluble. Insoluble means that it doesn't dissolve, it makes a solid. And so that should let us know that that's our precipitate, that's our solid. We should double check the sodium sulfate, and sodium, actually if you look down the list, anything with sodium is soluble, meaning that it would dissolve in water. Think about sodium chloride, table salt. Na here with Cl is soluble. Na with sulfate is also soluble. So now we know which one is the solid in here. All right, so now let's take off these question marks because we know that this is our solid and this was not solid. I do find that kind of confusing because insoluble means that it doesn't dissolve and that's your solid. This is the insoluble product, that's the white solid. The soluble one means that it dissolves, and so that's why we would write AQ there. So thinking back to having the different ions that kind of switched who they were bonded with, that should kind of give it away what type of reaction this is. And again, remember, we have 2 to choose from. We have double replacement and combustion. And if you were thinking it's a double replacement reaction, you're absolutely right. All right, thanks Panthers for joining us. Stay tuned for the last reaction on combustion. Panthers, one last thing that I forgot to tell you. We talked about what magnesium sulfate is, what sodium hydroxide is, Epsom salt and soda ash. And our product, our solid that we made, I didn't point out that magnesium hydroxide is more commonly known as MOM, or milk of magnesia, where would you find milk of magnesia or magnesium hydroxide? It's the main ingredient in liquid Tums. And one of the common slogans for that is to take mom in the AM for a BM in the PM. Hope that's not an issue you have. See you later, Panthers.